In this first session, we'll be dealing first with the mechanics part. In the mechanics one, we'll be covering the concepts concerned to the kinematics, NLMs, and so these chapters will be seeing more things, please. So we'll be discussing some sums in which are involved with the concepts also we'll be discussing. So coming to the today's first question, a particle is projected uh, in the a particle is been projected in this case, please. So when you go through the question, it's certain velocity. So since it has been projected with certain velocity at an angle of alpha above the horizontal from the foot of the inclined plane of inclination is 30 degrees. If the particle strikes the plane normally, alpha, then he is asking what will be the alpha, where alpha is an angle of the projection with respect to the horizontal. So if we try to draw the diagram for this one, so if it will be the horizontal, consider this one. So this is our inclined plane. Inclined plane, he has given some 30 degrees to the inclination. Now, if we consider that this particular thing or in this direction, if I take this as an x-axis, and this is the direction in which if I take this as an y-axis conditions, please. Okay, so now accordingly you can that means from here I'm projecting a particle like this and it is striking the plane normally. This is the one. That means it is hitting the plane normally like this. That means it is making an angle of 90 degrees to the inclined plane. And this total angle is going to be, he's mentioned it as this entire angle of projection, he has mentioned it as an alpha. So the angle of projection will come out to be an alpha minus 30 degrees. So it's an alpha minus 30 degrees conditions, please. Since G is going to be acting in the downward direction, since acceleration due to gravity is going to be acting in the downward direction, the acceleration which is being perpendicular to the, that is along the y-axis will. This angle is also 30 degrees. This is G cos 30, which will be acting along the negative y-axis. And another component of the acceleration due to gravity that will be acting in this direction. So this component I'm writing here, this is going to be the G sine 30 degrees. So these are your two components which are going to be the acting. So this is acting along the x-axis and this is along the y-axis. Unlike in the normal projectile where the acceleration along the x-axis will be zero, here it won't be the case and you are projecting with certain velocity u. So what you can analyze when you read the question carefully, we can analyze that since it is falling vertically onto the plane, that is, so velocity, that is a final velocity along the x-axis, Vx has to be 0. So velocity along the x-axis should be 0. Since it has been falling, I'll redraw the diagram here again. So it has been falling, this angle is 30 degrees and it has been falling vertically like this. So velocity along the x-axis is equal to 0 after time of flight or after t, after time t. Then according to the relation, Vx can be written as an ux plus acceleration along the x-axis into t. So as I have mentioned over there, the acceleration along the x-axis, this we have taken as an x-axis. Acceleration along the x-axis is g sine of 30 degrees. So now 0 is equal to u into velocity along the, this is cos of, angle of projection is alpha minus 30 degrees. And since it is directed towards the negative x-axis, so I can take it as a minus g sine 30 after a time of flight. This is your time of flight. Okay, so time of flight we have from this relationship, we'll be getting the time of flight relation as this is u cos of alpha minus 30 degrees by this is g sine 30, right, sir? So this is your time of flight from this relation we have got. But the actual definition, what actual formula, actual time of flight is that is t is equal to 2u sine of alpha minus 30 degrees by the component of the g along the y-axis g cos 30. So this is also time of flight and this is also time of flight. Let it be the equation 1 and equation 2. So now 1 is equal to 2. Equate them, please. So from this one, you'll be getting it as an that is 2u sine of alpha minus 30 by this is g cos 30 is equal to. You can write it as an u into this is cos of alpha minus 30 by this is g sine 30 degrees. So remove the common terms here. This can be removed. So from this one, I can write it as an this is tan of alpha minus 30 is equal to 1 by 2 tan 30. So 1 by 2 tan 30 is root 3 by 2 value. Or from this one, we can go for the alpha is equal to, if I take this as an alpha, alpha is equal to 30 degrees plus. This is tan inverse of root 3 by 2. So this is our final alpha value. He has asked this one to find it out. So 30 plus tan inverse of root 3 by 2. Your option 1 is the correct option. It's a single answer question, so please be careful of this one. Next one. Coming to our next question, in the figure shown. So what is in the figure shown? Figure this is spring has been connected M and to M. Okay, let's go through the question carefully. Block A is there of mass M is attached to the one end of a light spring, and other end of the spring is connected to the block B of mass 2M, fine, through a light string. A is held. What do you mean by A is held? So A is been stopped not to move and B is obtained in equilibrium. Fine. Now A is released. So when A is released, the acceleration of the A after an instant is A. Okay. That means he has named the acceleration of the A to be the small a. Now the same thing is repeated with the B. In the sense B is held now and it is released. In that case, acceleration of the B is going to be the B. He is asking the A by B value is going to be how much. Fine. These are the things we need to find it out, sir. Okay. So for the first case, if I go, this is case one. I'll write it here. So for the case one, where what we are doing is when A is held, so that means A you are holding, A is held, it's not, you are not allowing it to move. Now in that situation, when we write the FBD for the block diagram of the B, free body diagram for the B if I write it. So what are the forces that will be acting? Upward force is going to be the T. So downward force is going to be the 2mg. Since it is attaining the equilibrium, you can write T is equal to 2mg value of the tension. Okay, now this is the first part we have written tension, we have got it as in 2mg. Now, so in the same case, when A is released now, when A is released, so what will happen when A is released? Now, if we write the block diagram for the A, then what are the forces that will be upward force is going to be the tension and downward force is going to be the mg. Then if I write suddenly it is been released, so if it is coming in the downward sense, if I take it like this, or else in this situation that is mg, or this is mg minus p is equal to mass into a. This is acceleration of the a. So from this one, and earlier we have got the tension to be T is equal to 2 mg. Substitute here. So this is going to be the 2 mg is equal to m into acceleration of the A. That implies acceleration of modulus of acceleration of the A can arrive will be is nothing but the G. This he has named it as an E. Fine. So this is our case one. Now coming to the case two. So what is your case two? When B is held. So what will happen when B is going to be is held in this case? So when B is held, that means the A should be in the equilibrium. Then free body diagram for the A can be written as that. So go for the free body diagram for the A, sir. So tension will be upwards, and since it is attaining the equilibrium, this is T. So T is equal to mg. We have got it. Now when B is released, same situation. When B is released. So what will happen when B is released? So if I write the block B's, so downward force is going to be the 2 mg and tension is T. So let me imagine this has been coming in the downward sense, please. So it's going to be the 2 mg minus tension is equal to 2m into acceleration of the B. Since T is equal to mg, substitute here, so it will become mg is equal to 2m into acceleration of the B. Remove these two things. So acceleration of the B will become as an g by t. This he has named it as an B. Finally, he is asking A by B is going to be how much. So A value we have got it as a G, and B value we have got it as an G by 2. Then the ratio is going to be the 2. So this is an integer sort of a question, please, or multiple. Okay, though this value is equal to 2, integer type question. So next question, please. Now coming to the third question. So this question is based upon the law of conservation of momentum, and that is a major thing because no external force is acting on the system. So let's go through the question carefully. So mass small m is being released from here. From A, it has been released on smooth wedge mass. This mass is also small m. When the speed of the wedge, what is the speed of the wedge? He is asking. When the ball reaches the point B, fine at this particular instant. So if the ball is reaching to this particular point, what will be this particular height? So h can be written as an h is equal to, from the base it will be obviously the r minus r sin theta. From the here if I write it as an r minus r cos theta, or from the base you can directly take it as an r cos 45 degrees, which is equal to the r by root 2. So in any way you can put it down that particular thing, or else from the top if I write it, it will be the some other case. Now let's first I'll write out the, let v1 is the velocity of the wedge. Velocity of wedge, and v2 is the velocity of ball. Okay, so these are the things that we have defined. Now from law of conservation of momentum or linear momentum, if I write it, then what will happen at this particular instant? Since it has been moving in this direction, velocity v1, it will have the two components of the velocity. This is v1 cos 45 Another component will be the V1 sine 45 in this case. Since it is moving towards the right side, so this will be towards the left side. That will be the, sorry, ball is V2's. Okay, this is going to be your V1. Now conservation, if I write it, M into V1 along the x-axis should be equal to the ball is moving relative to the wedge. So V2 cos 45 minus V1. So this is our first, from this one mass is same. So that is 2V1 is equal to V2 cos 45 here. Cos 45 is 1 by 2. So from this one we have got the relation V2 is equal to 2 root 2 times of the V1. This is a very important relation we have got from the law of conservation of linear momentum situation. Fine, next one. Now let's apply the law of conservation of energy. So when we apply the law of conservation of energy, what is the initial energy that it is being possessed is going to be, or else final energy, anything. So that is, since the potential energy is decreasing, so loss in potential energy is equal to gain in kinetic energy. Loss in potential energy should be equal to the gain in kinetic energy. So what is the loss in potential energy is, it is coming to the height of mgh is equal to, who is gaining the kinetic energy? Wedge is gaining the kinetic energy along the x-axis, and ball is gaining kinetic energy along the x-axis with respect to the on the wedge. So v1 whole square plus half m velocity of the ball along the y-axis, v2 sine 45 whole square. So these are the things, please. Now, if I substitute these relationships, this is going to be the mg into r by 2 is equal to r by root 2. So this will be the half m into v1 square plus half m into, this is v2 by root 2 minus v1. I can substitute the v1 value and v2 value from there. We have got, I just write it here. From here, v2 is equal to 2 root 2 v1. Let's put it here. v2 is equal to 2 root 2 times of v1. So we need to use this relation whole square plus, this is half m into v2 by root 2 whole square. So remove the m and the half from either sides. So this will become as n. And take the LCM also. This will be the root 2 gr is equal to, this will be the v1 square plus, if I substitute the v2 as 2 root 2 v1, root 2 cancel out over there. So this will be the 2 v1 minus v1 square plus, this will be v2 again, root 2 cancel, this will be the 2 v1 whole square. So I'm eliminating the v2, that is the velocity of the ball. He has asked the velocity of the wedge. I'm trying to find out the v1. So from this relation, it is root 2 gr is equal to, it will be the v1 square plus v1 square plus 4 times of v1 square. From this one, 6v1 square is equal to the root 2 gr. From this one, v1 square is equal to the root 2 gr by 6. 6 can be written as a 3 into 2, or the same thing can be written as a gr by 3 root 2, or from this one, v1 value is equal to root over gr by 3 root 2. So this should be a relation of the wedge conditions he has asked. So we have found out this particular thing, velocity of the wedge. Next one, in the given figure shows a block of mass m placed on a smooth wedge of mass capital M. Okay, here this is your small m is placed on the capital M. Calculate the value of the m dash and the tension he is asking. That means it's a multiple answer question, so that the block m will move vertically downwards with an acceleration. That means this m has to come down with an acceleration of 10 meter per second square. So when it is moving with an acceleration of the 10 meter per second square, then what will happen at this particular instant? Then the contact of this is M, since it is then N with capital M is 0 or no contact, or the N value will become 0. That is, the normal reaction is going to become 0. So since it has been acting in this direction, so what are the forces that will be then if I write the constant sort of a relationship is? So here the tension is going to be pulling in this case. Suppose if it comes by a distance of some x here, or this distance is x, then it will move by a distance of some y. So now if I write this is your angle theta. So from this relationship, we can write this particular thing, that is along the acceleration from this one, that is tan theta can be written as a. So from this relationship, you can go for the tan theta is equal to, that is y by g by a, or I'll write it as an y by x. Later we can put it down. So from this one, that is x is equal to y cot theta. If I differentiate this one, so acceleration a is equal to g cot theta. So this is a constraint equations, we can write it. So acceleration of the system is in this direction, it has been accelerating like this. So we have got the first constraint relationship, and the normal reaction is equal to 0. So since in the normal reaction is equal to 0, this is the tension. Here also the tension will be there. So that under the equilibrium situation, that is accelerating m1g is equal to the, since it is coming in the downward direction, and or else minus tension is equal to, this can be written as an m dash into a acceleration, and but tension T is equal to m into a. Since small m is not in contact, we cannot go for that particular thing. So from this one, this we can substitute, and m dash g is equal to. So I'm substituting this one. This will be the m plus m dash into a. So from this one, we have got the value of this one. A value substitute here. M dash g is equal to, this will be the m plus m dash into, it is g cot theta. M plus m dash into g cot theta condition, sir. So g remove, please. From this one, what is the value of the m dash? So from this one, m dash is equal to m cot theta plus m dash cot theta. Take all the m dash to one side. M dash is equal to 1 minus cot theta is equal to m cot theta. From this relation, we have got the mass m dash is equal to. So first part of the question we have got, this is 1 minus. Now verify which option is going to be satisfied. M dash is equal to m cot theta by. So first option is correct. Now we need to go for the tension in the string. So to calculate the tension in the string, I can substitute the same relationship here. So from this equation, from the same equation, I can write the tension T is equal to, this is equal to the m dash of, or else let me write in a normal way, since rather than going directly. So from this one, it is m dash into g minus t. is equal to m dash into acceleration here. So we can substitute the acceleration over there. From that one, t can be written as an m dash into g of 1 minus cot theta. Then if I substitute the m dash value here, m dash is m g cot theta by 1 minus cot theta of, this will be the 1 minus cot theta. We remove these two things. So from this one, tension T is equal to mg cot theta. So this is your tension value. So which option is there? Okay, option 3, he has mentioned it as a time terms. So this can be written as an mg by tan theta. So this is option C, and this is your option A. Okay, so multiple answer question. Next one, please. A heavy particle is there. Is the heavy particle is tied to end A. Okay, in a string of length 1.6 centimeters. The other end is going to be how much? Other end is O. Is fixed. It is been fixed at that particular point O. Great. It revolves in a conical pendulum sort of a thing. So as the conical pendulum is with, it is making an angle 60 degrees with the vertical. Then he is asking the different things, please. Okay, so we'll be drawing the conical pendulum here. So let this be the point 2. From here, it is being suspended and it is been moving in a horizontal circle like this. Let us imagine. Okay, so that means it is being rotating in this case, please. So lifting it to a certain height, that's okay. This is going to be some 60 degrees he has mentioned. So tension will be there in this case. This is your radius and the total length of the string is going to be the L. So this is the one he has given. Now, if I resolve the tension into the components, so upward component will be the P cos 60, and the component that will be acting towards this direction is going to be the T sine 60, and that should be balanced by mg, and this is mv square by r. So from the diagram, you can write that r is equal to L sine 60, that is root 3 L by 2. Let me take this one. Now from the diagram, I can write that this is T sine 60 is equal to mv square by r. So what is T sine 60 is? T into root 3 by 2 is equal to mv square by r value root 3 L by 2. So from this relationship, you can write it as an 3T by 4L is equal to mv square. So first one I have got something. Next, T cos theta can be written as an, this is mg. T cos 60. T cos 60 is equal to mg in the sense T is equal to 2mg. This is your second one. Substitute the second one in the first equation, please, here. So from here we can get the 3 by 4 times of L, and the type tension is 2mg. This should be equal to the mv square. Remove these two things. This goes for 2 times here. So v square is equal to 3gl by 2, or v is equal to, from this one, v is equal to root over 3gl by 2. Okay, so he has given the values, so we need to find out the values. So we are trying to get the C option. Let's try to get that one. Substitute the values, please. Root over 3 into, this is 9.8 into 1.6, which is 16 by 2. So if I go for an approximations things, it will be the 10 to the power of minus 2, or this is 10. So this should be approximately equal to the root 3 value. I'll put it as it is. 8, and this is going to be, this will be somewhere around 2.7 or 2.8 terms into root 3 nearly value I'm taking. So that means your option C is correct. We have got the velocity part first, meter per second. Next one. So what are the other things he has asked? Time period. Tension in the string is double the weight. Okay, we have got there T is equal to 2 mg. We have proved it. So this is your option B. This is your option C. Next, option B, option C we have got. So first one, time period and centripetal acceleration. Let us go for the centripetal acceleration. Centripetal access. So what is the centripetal acceleration is? AC is equal to V square by R. What is your V square value is? 3G L by 2 by R value is root 3 L by 2. L by 2, L by 2 goes off here. So this will be equal to the root 3 times of G. That will be equal to the 9.8 into root 3 meter per second square. So AC value root 3, fine. This is your option D, sir. Now going for an option A. So how can you find out the time period for the option A? So time period T is equal to 2 pi into frequency, or the same thing can be written as in 2 pi into radius into velocity. So substitute these values. 2 pi into radius is root 3 L by 2. Velocity is going to be obviously, we have got here 2.7 into root 3 times. So we can remove the root 3, sir. Here 2 will also get. So 2.8 or 2.7, 3.14 into 1.6 into. According to the question, I'm changing this as an given answer 2.8 root 3. So 2.8. So on solving this one, we can get it, or else as he asked in terms of the pi only. Okay, so no need to convert this one. Since it is in the pi terms, just mention it. So that is 16 by, it will become as an, so pi only. So this is 16 pi by 28 in the sense 4 pi by 7. This is your option A. 4 pi by 7. So all of them are correct in this case. Multiple answer question. So next session, sir. Two graphs are there, fine, of same projectile motion projected from origin are shown along the x-axis, fine, E is horizontal direction and y is in the vertically upward direction, great. So acceleration due to gravity also he has provided. So two graphs are there. These two graphs are concerned to the same projectile motion, are projected from the origin as shown. So x-axis is taking the horizontal direction, y-axis is going. So he's asking the speed. What can be analyzed from the first graph? So here the y value is there, that is 1 by the coordinates of this one is going to be the 1 by 2 comma 0. Okay, that means at, this is from graph 1. So first graph I'm taking at t is equal to, what is happening at t is equal to 1 by 2. Your vertical component of the velocity is becoming 0. So when the vertical component of the velocity will become 0 at the maximum height, that particular thing we know. Since Vy is equal to 0 at this one, in this direction, acceleration along the y-axis should be equal to the g. So let us substitute in the relation. Vy is equal to uy plus gt along the y-axis directions. Since it's a negative one, u is in the upward sense. 0 is equal to uy minus gt, or from this one, uy is equal to g is 10. Let us take it as an, and the time is 1 by 2, which is 5 meter per second. Velocity along the y-axis we have got. Now, when you study the second graph, that is Vy, So from graph 2. So from the graph 2, what you can write, sir, here? It is velocity Vy is becoming at x is equal to 2. At x is equal to 2, vertical component of the velocity is becoming 0. That means this should represent the half of the range. So now we have got the x, we have got the Vy, and in the same time, since it's a projectile motion for the same time, acceleration along the x-axis 0, this also we know. So x is equal to ux into t plus half ax into t square. This term is 0. So x is equal to 2 ux into 1 by 2 time. So ux is equal to 4 meter per second. So we have got the uy is equal to 5 meter per second. Let's verify. 5 meter per second. Yeah. So ux is equal to 4. So u is equal to initial velocity of the projection ux square plus uy square, which should be equal to the root over 4 square plus 5 square. So that comes out to be the root over 16 plus 25. That is equal to the root 41 meter per second. So option B should be your correct option. Next one. Okay, same question he has asked the maximum height and the angle of projection theta in the option. Okay, in the options he has asked the theta. Fine, but here is the maximum height. Let's try to find out both of them. So from the first graph, as I have written, from the graph 1, from the first graph, what you can say, sir? So Vy is equal to 0. Vy will is equal to 0 means that this is equal to half. So vertical velocity becomes 0 only at maximum height, h maximum. So how can you determine the h maximum then? So h maximum at that particular instant is equal to uy into t minus half g t square. Substitute the values, sir. So uy is going to be the 5 into time is 1 by 2 minus half into 10 into 1 by 2 whole square is 1 by 4. So that comes out to be the 5 by 2 minus 5 by 4, which is equal to the 5 by 4, that will be 1.25. This is your maximum height. Maximum height. So first part I have got. Now to find out the theta. So how to find out this particular theta? We have got the ux is equal to 4, which is equal to the u cos theta, and uy is equal to 5, that is equal to the u sine theta. On dividing these two things, tan theta can be written as an 5 by 4. That implies theta is equal to tan inverse of 5 by 4. That means it should be the option C. Here you can also find the half of the range, please. Since at x is equal to 2, your vertical velocity is becoming 0. That implies x should be equal to the range by 2. Since x is equal to range by 2, so range by 2 is equal to 2. That means range is equal to 4 meters. Like this also you can determine, but this is not asked in the question. You can go like this. Next question, please. The velocity time graph for the vertical component of the velocity only of an object thrown upwards from the ground reaches at the roof of a building as shown. The height of the building h meters is asking. Okay. It's a velocity time graph, sir. Since it's a velocity time graph, area under VT graph It gives displacement. In this case, vertical direction displacement is height only. So now go for the area of the graph. So area. Two triangles are there. One is half base into height. So for the first triangle, so half into base is 3 into height is 30 minus second one, sir. Second one is on the inverse relationship, please. So it will be the minus of half into base is this is 3. Then this distance is 1 and the height is into so this is 10. So now in this case, please, this is 30, sorry. So this will be the 15, or shall I write it as it is 90 by 2 minus 10 by 2, which is equal to the 45 minus 5, that is equal to the 40 meters. So he is asking h total height is going to be this much. So h by 5 value is going to be how much? So that is 40 by 5. That should be the 8. This is the one he has asked. 8 meters. So this is also meters. Next one is small block of mass M, which is the 2 kgs, is kept. And the rest condition here. Okay, that means initially it is in the rest position, bottom of the inclined plane, a mass of 9 kgs. You are applying a force of 210 newtons like this is applied on the wedge horizontally as shown in the diagram. All the surfaces are smooth. Determine the time taken in second by the mass to reach. So let us imagine that this is M is at the starting point. So he is asking what is the time taken by the M to reach to the top throughout this length L. So what is the distance it is traveling is, that is cos 45 is equal to 10 by hypotenuse is L. L is equal to 10 root 2 distance it is traveling. So just keep it aside. Now, since this much force has been applied, so F is equal to which two are moving? Capital M plus small m into acceleration is E. So that is 210 is equal to 9 plus 2 kgs into acceleration. So acceleration is equal to 210 by 11. So what can be this particular case, this one? So this should be equal to the approximately, if I go 1, and the leftover term is going to be the 10, this is going to be the 9, 99 point is there, it will be the 0 point, again 9. Okay, I'll take it as approximately it is 19 meter per second square. Just for the case, I'll go for the nearest integer here. So now acceleration we have got. Now this acceleration, the small m feels the same acceleration in the opposite direction. So which is going to be taking it in the upward direction is a cos theta in the upward sense. Downward direction, the component is going to be the g sine theta is pulling it in the downward direction. In that sense, then your resultant acceleration will be equal to the a cos 45 in the upward direction minus g sine 45 in the downward direction. A is 19 by root 2 minus this will be the 10 by root 2, or the resultant acceleration is 9 by root 2 meter per second. So block M is moving. So block M is moving upwards, moving up with acceleration of that is resultant acceleration is 9 by root 2 meter per second square. This is the information. So it is traveling a length also we have got L is equal to how much? That is 10 root 2. It is traveling a distance or displacement L is equal to 10 root 2 meters. He has asked the time. Now substitute in the S is equal to ut plus half a t square. Since it is starting from the rest, initial velocity is 0. So that is 10 root 2 is equal to half into resultant acceleration 9 by root 2 into t square. So from this relationship, t square is equal to 10 into 2 into 2 by 9, or this is 40 by 9 t square. T is equal to root over, this is 40 by 9 condition, or approximately I'll go for this one, it will be the 2.1 seconds or like this. Next case. So last one, the path of the projectile is represented by the y. So he has given some equation for the path of the projectile, sir. That is y is equal to px minus qx. It is in the form of general path of the projectile as a parabola. That is generally in the table, when we derive, we'll take the same thing as an A and B. Here he has taken it as an P and Q. Now we need to match the following. So first condition is range. So what is the range condition? Range is obviously A by B. How you can say so? A is nothing but if I compare, so here I'll solve. So your standard equation is y is equal to x tan theta minus g by 2u square cos square theta into x square. This one he has mentioned it as, and this is px minus qx square. So from this one you can say that p is equal to tan theta and q is equal to g by 2u square cos square theta. So from this one, first one range I'll go. Range is equal to p by q. How, sir? That is tan theta by g by 2u square. This is 2u square cos square theta. Tan theta can be written as an sine by cos. One of the cos will be go u square. This will be sine theta into cos theta by g. So that means your first one is matched with whom, sir? Let me see. First one is matched with the A. So this is your first relationship I have got. Now coming to the second part, maximum instead of this one, I'll go for the fourth one, tangent of the projection. On comparison here, what is the tangent of the projection? Tangent of projection. That implies tan theta should be equal to the P. So it is a fourth one. Fourth is being matched to the P. Where is P? B. So fourth has to be matched with the B. Next one, the time of flight and the maximum height. So if I go for the maximum height case, remaining two options are there. Let us check it out. This one, maximum height means maximum height general formula u square sine square theta by 2g. So u square sine square theta by 2g we have got the tan theta is equal to this much. From this relationship, sine theta by cos theta is equal to p. From this one, sine theta is equal to p cos theta. So if I replace here, so this will be equal to the h maximum is equal to u square into p square cos square theta by 2g. Or else let me take this one as an p square into u square cos square theta by 2g. From this relationship, u square cos square theta can be replaced with the g by 2q. So replace that one. It will be the p square into g by 2q by 2g. So your g will goes off. So h maximum will be equal to the p square by 4 into q. So this represents your second option. That is 2E is related to which one, sir, here? Sorry. 2E is related to the C. So second one is related to the C. Now go through the option 1A, 2C, 4B. 1A, 2C, 4B. You can have it. Obviously, we'll be getting another thing. We'll see first thing 1A, 2B, 2C, 1A, 2C, 1A. This is not the case. This is not the case. 1A is there. 2C is only this option. And obviously, fourth one is B. So these are the things. So your answer is going to be the B, sir.